Okay, good day. This is dual enrollment pre-calculus. I am Mr. McCulley, and this is lesson 23, trigonometric applications. So let's get right to it. Today we're going to solve some problems involving right triangles. We're going to solve problems involving directional and bearings, and solve problems involving harmonic motion. Now, the good news is that there's very little new math that goes with this. Most of it is a couple definitions that we're going to have, and everything is just applying all of the knowledge that we've learned so far in this particular unit. So the first definition I want to talk about is bearings in trigonometry. Bearings measure an acute angle, path, or line of sight line made with a fixed north-south line. So if I see, as an example, someone saying uh, north 32 degrees west. What that literally means is if I look at a north-south line here, I'm going to start at this north line and make an acute angle towards the westerly value. So I'm going to start here and move this way. All right, so this angle here, it's going to start in the northerly direction and move 32 degrees towards the west. So this angle right here is 32 degrees. Now, I could also say south, say 50 degrees east. All right, so if we're doing that particular one, I'm going to start in the south direction and I'm going to move towards the east 50 degrees. So here is my east, and I'm moving that direction from south 50 degrees. All right, harmonic motion. Harmonic motion follows something like this. D equals A sine W theta, or D equals A cosine W theta. Uh, Displacement is the amplitude. So when they say what is the displacement, they're talking about the amplitude. The period is always going to be 2 pi over w, and we've seen that before. But the frequency is the reciprocal of that. And be careful, because there's a lot of times where it almost feels like they're mixing these together. So period 2 pi over w, frequency is w over 2 pi. All right. So what's a couple of questions that you get to see? Yeah, this example is going to be solve the right triangle. And so if you recall, anytime they tell you to solve a triangle, they're asking you to fill in the blanks for all of the unknown parts. So when I look at this particular triangle right here, I clearly see that, you know what? I think I may have given away too much information. So we're going to erase that. We're going to start with that. I clearly see that the side A, so this right here is going to be my little a, and so my little a is 25, so we'll put 25 there. My little c will be across from my angle C, so we'll put a 35 there, and we need to figure out what B is. We know that C is a right angle, so it's 90 degrees. So we need to figure out the rest of the parts. Now, not every single answer is going to need trigonometry. For example, when we solve for B, since we know that this is a right triangle, we can use the Pythagorean theorem and say that 25 squared plus B squared is equal to 35 squared. So if I go 35 squared minus 25 squared, I get 600. Well, let's see here. So my B squared is equal to 600. That means B is going to equal the square root of 600, which would be, let's see here, 100 times 6. I think that's the smallest, or the biggest perfect square that I can factor out of 600, because 6 does not have a perfect square as a factor. So I'll have 10 square root of 6. So 10 square root 6. And then now that we have that, we want to figure out what angle A and angle B is. Now, in general, and I don't know if you've had physics or not, we want to try and use as few derived answers as possible. So if we can, we want to find out what A and B is through only the information that was given. Now, sometimes you can't, and that it can't be avoided. But if you can avoid it, you should. So if I want to figure out what angle A is right here, I know that I have a given 25 as an opposite side and a given hypotenuse as an, yeah, given hypotenuse 35. So I could say that the sine of theta is equal, and you know what, let's use the right term there. Let's say the sine of A is equal to 25 over 35. Therefore, A would equal the arcsine of 25 over 35. And we can go right to our graphing calculator. Since we're talking degrees here, we should probably check the mode and come down here, change that to a degree, and we'll quit. So second, arcsine 25 divided by 35, hit enter, and we have 45.585. 45.585. So 45.585 degrees. Now, here's what I was talking about when I said using a derived answer. We know from geometry that if you add up the three angles of a triangle, they'll equal 180 degrees. So I am only missing one. I could go 180 minus 90 minus 45.585, but I am using a derived answer. I have rounded this answer, so there's the possibility of a little bit of error. Now, it's not that big of a deal in this particular context because we're going to get the right answer, but again, we want to be in the habit of not using derived answers if we don't have to. So now I want to solve for B without using a derived answer. And if I talk about B in the context of this right triangle, now the 35 still stays the hypotenuse, but the 25 is now the adjacent side. So I can set up a second trig expression. Cosine of B is equal to 35. Oops, did that wrong. Let's get it right. Equal to 25 over 35, and by the same token, same method that we did over here, B would equal the arc cosine of 25 over 35. So if I grab my graphic calculator, second, let's see here, cosine 25 divided by 35, and parenthesis, hit enter, 44.51415. 444.415. So 44.415, and if you added those two, you get 90. And so we feel fairly confident that there are our correct answers. Next example, it says the front of an A-frame cottage has the shape of an isosceles triangle. It stands 25 feet high, and the angle of elevation of its roof is 70 degrees. What is the width of the cottage at its base? Okay, well, we can draw that. We've got a nice isosceles triangle tool right here, and we can say that if I were to draw a line, I don't like that line for this particular, let's make a small line, let's go like this. If I were to draw that line right there, we could say that this is 28 feet, and that the angle of elevation, so starting at horizontal and going up, is 70 degrees. They want to know this whole length right here. We'll call it big B for base. All right, so if it's an altitude, then this has to be a right angle. And so I have an angle measure, I have an opposite side. I'm going to call this X for right now. And whatever X is, we'll double it. We'll say B is equal to 2X. And then that'll be our answer. So I have an opposite side and adjacent side. That means tangent. So the tangent of 70 will be equal to the opposite side, which in this case is 28, over the adjacent side, which is X. And remember, if you have a expression like this, you can take the X and the tangent of 70 and just switch them. So X equals 28 over the tangent of 70 degrees. And so X equals, grab our calculator, 28 divided by the tangent of 70 Now that's the value of x, and that's fine, but we know that the value that we're looking is double that, so we're going to multiply that by 2. So 20.8, or excuse me, 20.382 is our answer. 20 point, that's x. B is 20.382 feet. Proper units. Okay. Next example, when a plane leaves a runway, its angle of elevation is 18 degrees and its speed is 275 feet per second. How long would it take for the plane to climb to 1,000 feet? Okay. See if we can do that one. All right, so we're trying to follow this plane that's taken off, and it is going at, let's see here, 275 feet per second. All right, and it's climbing at 18 degrees. So I want to know how long it takes to get to 1,000 feet. Well, that's not too bad. What I'm going to do first is I'm going to find the vertical speed. And in this particular instance, the vertical speed we're going to call y here. And so using the opposite side and the hypotenuse, we're going to say that the sine of 18 degrees is equal to y over 275. I put an x there, and it should be a y. So let's rewrite that, make sure we're real good. And 275. So y equals 275, the sine of 18. Graphic calculator, 275 sine 18, close parentheses, enter. So it is, if it's traveling up at an 18-degree angle at 275 feet per second, then it's traveling in a directly upward distance at 84.980, because the 6 is going to round it up. 84,980. So y, vertical speed, y equals 84.980 feet per second. All right, so how long does it take to climb to 1,000 feet? Well, we know that velocity equals distance divided by time, and therefore distance would equal velocity times the time, and therefore time equals distance divided by the velocity. Yeah, we can do that. Distance, let's do that right. Equals the distance divided by the velocity. And so I've got 1,000 feet divided by 84.980 feet per second. And so our units will cancel, because when you take the reciprocal, or when you divide by a fraction, you take the reciprocal, feet will be on the top, feet will be on the bottom, and all will be left is seconds. There's our unit analysis. So I am going to go to my graphic calculator, go 10,000. There's 10. 3 more zeros gives me the 1,000 divided by second answer. Hit enter. It'll take me 117.675. 117.675. 117.675 seconds. And we are done there. All right, well, that's all I got today. The novel Dune was a heavy influence on the creation of Star Wars. Dune was released in the early 60s. And incidentally, Denis Villeneuve, director of the new 2020 Dune remake, calls Dune Star Wars for adults. I'm looking forward to that one as well. See you in class, folks. That's all I got. Have a good day.